Human beings exert energy in everything they do. Energy helps us work. It even enables us to have a little fun now and then. Energy is found all around us and takes the form of either potential or kinetic energy. These two kinds of energy can be found in several forms. For example, electrical, nuclear, and thermal. Each of these forms of energy can be transformed into other forms. A classic example of this conversion is a waterfall. But we're not talking about just any waterfall. This is Niagara Falls. It produces much of the electrical energy for the eastern United States and Canada. However, before the electrical energy is produced, several energy transformations must take place. The first transformation is from potential energy to kinetic energy. The water at the top of the falls has potential energy because of gravity. As the water moves over the falls, the gravitational potential energy is transformed into mechanical kinetic, or moving energy. Water's kinetic energy must then be transformed into electrical energy, a task performed by a hydroelectric generator. Water from the river is diverted into pipes before it reaches the falls. As the water flows downhill through the pipes, its kinetic energy does work. It rotates massive turbines. The turbines are parts of electric generators, machines that generate electrical energy. The mechanical energy of moving water is transformed into mechanical turbine energy. The movement of the turbines produces electricity. The overall result is that the gravitational potential energy of water has become electrical energy. From Niagara Falls to your own backyard, transformations from one form of energy to another take place and power everything we do. Explain how gravitational potential energy is transformed into electrical energy at Niagara Falls. As you watch this segment, think about the energy transformations that take place during skiing. Few skiers have the opportunity to ski different slopes around the world. But these women are skiing where only a few athletes have been brave enough to go, the snow-covered peaks of Lebanon. Lebanon's unmapped terrain, unpredictable weather, and biting cold make the slopes here some of the most difficult around. These extreme skiers are up to the task. They have devoted their lives to conquering the most dangerous slopes on Earth. Though all of the skiers are top athletes, Kasha Rigby, an American pro skier, is one of the best skiers in the world. But even the most skilled of these extreme skiers could not enjoy this sport without causing several transformations of energy. It begins with the hardest part, walking uphill. Each step is more and more difficult as the mountain becomes steeper. Carrying a heavy pack filled with food and supplies doesn't make it any easier. It takes energy to climb up the mountain. The chemical energy from the skiers' food is powering their muscles. Their muscles produce movement, or kinetic energy. With each step up the mountain, some of that kinetic energy from muscle movement is transformed into potential energy. The higher each skier climbs, the more potential energy she has. At the top of the mountain, each skier has the greatest amount of potential energy. As they start moving downhill, each skier's potential energy starts to be transformed into kinetic energy. As she moves downhill, Kasha's gravitational potential energy continues to be transformed to kinetic energy. But how does she slow down, turn, and stop? Part of the answer is friction. By switching her weight from one ski to another, Kasha can control the amount of friction underneath each ski. Increasing friction will decrease her mechanical kinetic energy. But since energy can neither be created nor destroyed, where did that kinetic energy lost to friction go? It may not seem apparent on these icy slopes, but friction transforms mechanical kinetic energy into thermal energy, or heat. The conversion of kinetic energy into heat energy is an example of the law of conservation of energy. The kinetic energy isn't lost, it's transformed into heat energy. By shifting her weight, Kasia can use friction to stay in control of her speed and make turns while going down the mountain. In fact, Kasia can apply so much friction that all of her kinetic energy is transformed to heat energy. In other words, she stops. By the time she reaches the bottom of the slope, Kasia has transformed all of her potential energy into kinetic energy, and then into heat. Her downhill adventure is over, but she is only one uphill hike away from building up her potential energy and starting down the mountain again. What is the difference between potential energy and kinetic energy?